There we go. Okay, functions. So first bit, we're not doing. So we'll just kind of incorporate that as we go. Okay, hopefully this is a review. The first little bit's gonna be a lot of review of math 12 or math 11. I know some of you did that first semester last year. That's fine. It's just gonna be a bit of algebra. So polynomial functions. So this is the fancy way mathematicians would write the general form of a polynomial function. You guys are probably just used to this kind of stuff. That's a polynomial, all right? You guys know what type of polynomial that is? What does the graph of that look like? Just a general shape. It's a parabola, and you know that because of the 2, right? Okay. So if we have this polynomial function, f of x is equal to 7x cubed plus x to the 4 minus 8x squared plus 5. What is the degree? If I said degree, what are they talking about in terms of a polynomial function? What's the degree of this? 2, right? It's the highest exponent. So what's the degree of this polynomial? 4. It's the highest exponent. So this degree is 4. Leading coefficient is, anybody remember? The number in front of the term with the highest degree. So in this case, it would be 1, because this is the expression, the term with the highest degree, and the number in front of that is 1. And constant term is the one without a variable. So in this one, it would be 5. All right. Okay, linear functions. This is grade 10. So in grade 10, you only studied straight lines, basically. They're writing it as f of x equals ax plus b. You're probably used to y is equal to mx plus b. Does that ring bells? What does the m stand for? Or represent? Yes. M is the slope. And b is Y-intercept. I'll just write y-int for my y-intercept. You'll see that I shorthand everything. Okay. How do you know if something is a straight line? Oh, there you go. What's up? What's up, Marty? You're interrupting my recording. Okay, so how do we know if something is a straight line? Mr. Late gave us a pseudo right answer, not totally 100% right. But if I said, is that a straight line? No, that's a parabola, right? It's got a 2 on the x. Is that a straight line? Or a linear line? Anybody know what that graph actually looks like? We're going to study cubics later on in the course. Yeah, it's a wave. This is not part of what this unit looks like. That. The way you know you have a straight line is the exponent on the x is 1. If it's anything else, if it's a half, if it's a third, if it's square root is a half. If it's 2, 3, 4, 18, 58, whatever, it is not straight, not linear. Okay, that's why it's y is equal to mx plus b. M is the slope, b is the y-intercept. So, oops, sorry. There you go. If I asked you to graph this function, y is equal to 3x plus 1. Right away, you look at it and you go, is it linear? Yeah, because the exponent on the x is 1. Okay, so we know it's a straight line. Do I know the y-intercept? What is it? 1. Oh yeah, you don't have to raise your hand in my class, just yell out. Okay, so it's 1, so I just mark 1. The slope is 3. Now, what does that actually mean? It means 3 over 1, right? That's the same as 3. What does the top number represent in terms of slope? There's 2 words, blank over blank, rise over run. So the rise is 3 and the run is 1. So if you start there, you count up 3, 1, 2, 3, and over 1, there's your second point, draw a line. You're going to see quickly in my class, I'm just about making quick sketches. That's what like Math 12, we'll look at more detailed stuff. And if you do take calculus, it's a lot of being able to quickly sketch a graph. Because really all these equations represent, that's one way of representing a graph, okay? And so as you go up in math, you will see that you want to kind of interchange. And if you can look at an equation and sort of visualize a graph or make a quick sketch of a graph, it'll help you solve problems, especially when we get into calculus. Okay, y is equal to 5. Straight line, curve. Exactly. So y-intercept of 5. There's no x, right? So I could have written it this way. 0x plus 5. Nobody ever would. Or sorry, there's no x. But what's the slope when I write it that way? 0. And the slope of 0 is horizontal, right? So this is just called a constant function. Okay. We should do domain and range too. You guys remember domain and range? Do we know what domain, do you remember what domain is? Just this sort of definition. It's all the possible x values. So if you are, so basically what it's saying is, when they ask for domain, are there any restrictions? Are there any numbers you can't put in? So what can you not divide by? Divide by 0. And what numbers can you not square root? Square root 4. Square root negative 4. And square root negative. So as this function, so if we can't divide by 0, that means you can't have a variable in the denominator. Is there a variable in the denominator for this function? Is there a denominator? Essentially. I guess you can always write a denominator. But is there some number over x? It's just 3 times x, right? So there's no restrictions there. Is there a square root? So if there's no restrictions, do you know what you write for domain? All real numbers. And there's 2 ways to write that. So in math 11, you probably wrote that, XER, it's not really an E, it means X is in the set of all real numbers. All right, but everybody will just shortcut it and say XER. You can write that, means it could be anything. Or as you go on in math, and I'll use both in this class, you can write, those are supposed to be infinity signs. So from negative infinity, positive infinity with rounded brackets. And that, we'll talk more about that as we go through the course. The other way you can do domain is if you look at the graph and there's arrows on both ends, there's no restrictions. It goes on forever. Okay. What about range? Range is the possible y values, right? What's the range for this graph? Are there any restrictions on the range? Are there arrows on both ends of the graph? So it goes on forever in both directions, right? Up and down. So are there any restrictions? So what should I write? So if you're going to write it, that's called set notation. You can do that. So you can say negative infinity to positive infinity, or you could just write YER. Same thing. If you're going to take calculus, but for this class, YER, XER, I'm fine with that. What about y is equal to 5? So let's do domain. Are there any restrictions on the domain? Any x values you cannot put in? Go away. Any x values you cannot put in? Is there a square root around the x? Is there an x in the denominator? There isn't even an x in the equation. So there's no restrictions. So we would write XER or negative infinity to positive infinity. Now what about the range? Does the function go up or down? It's just set at 5. Doesn't change. So the range is just y is equal to 5. Okay. Any questions about that? Okay. Quadratics. So how do you know something's a quadratic? It says it right there. Degree 2, i.e. highest exponent is a 2. Okay. All right, they want us to use a graphic. We're not using a graphic. We don't need a graphic. So you look at this function here. Right away, you know this is math 11. This is like all of what math 11 was, right? It was just like quadratic, quadratic, quadratic. So you know this is a quadratic function. You know it's going to be some sort of parabola, right? It's going to look something like that or like that, up, down, upside down. How do you know if it's up or down? Yes, if you have a negative in front of the x squared, it'll open down. If it's positive, it'll open up. Now, we have to figure out the graph. So, zeros. There's another word for zeros. Anybody know what they are? There was 3 words for them, essentially. And it's what you did in Math 11 and Math 10, but mostly Math 11. Every time you saw a quadratic, if you didn't know what to do, you should, starts with an F, factor. All right? Do we remember how to factor? It's very important for this class. So, if it looks like this, we'll go down here and we'll just do it right here. b. We're going to factor this. So you write this, x squared minus 3x minus 18. So if I want to factor this, what we're trying to do, remember we're trying to create sets of brackets like that. What do we do? What do we look at? What two numbers do we look at to do this? Look at the last number, negative 18, and you look at this middle number, negative 3. I'm trying to find two numbers that multiply to this. Let's put it times. And add that. So what multiplies to negative 18 and adds to negative 3? Which one would be negative? There you go. Negative 6 and positive 3. And then all you do is put x's in front of them. X minus 6, x plus 3 factor. Is that ringing bells? Okay. All right. So now we've factored it. I want to know what the zeros are, which are also called the roots, which are also called the x-intercepts. Now they're not quite, they mean slightly different things. How do we find those? How do we find the x-intercepts or the zeros of these two things? Clue is in this word, zero. It's saying what makes each bracket 0. So what makes this bracket 0? Positive 6. So we can write x is equal to 6. What makes the second bracket 0? Negative 3. Those are your x-intercepts. All you need to go to the graph, positive 6, negative 3, and x-intercepts occur where the y value is 0. That's why it's what makes each bracket 0. If I now said, we're not going to do the vertex, the y-intercept, that is when x is 0. This is the x, or sorry, this is the y, and that's the x. So if I put x is equal to 0 into this equation, what number do I get out? What happens? What's 0 squared? 0. What's negative 3 times 0? 0. What's the only thing that's left? Negative 18. That is your y-intercept. So just mark it, negative 18. Does the graph open up or down? It's up, because it's positive in front of the x squared. All you need to do in my class is draw a parabola that goes through all of them. There you go. That's it. We'll talk about the vertex, but we're not going to find it. That's more math 11. Do we know what is the vertex? It's the lowest point when it's opening up. Like if it opens up, there's the vertex. If it opens down, there's the vertex. It's the highest point. So this is the vertex. We're not going to find it. More math 11. Not important for this class. That's all I need you to do. Make sure it goes up. Mark the x-intercepts. Mark the y-intercept. I'm happy. Okay. Okay. Let's just quickly do this and then give you a couple questions. So if I said sketch y is equal to x squared, the most basic parabola there is. Do you know where it's centered? 0, 0, right at the origin. So it looks like this. Okay. every other parabola, and we're going to do transformations as the next unit. This is a quick review of math 11. If I gave you that, y is equal to x squared plus 1, what has the plus 1 done? Moves the vertex up 1. If I wrote minus 1, what does it do? Moves it down 1. Still opens up. What if I wrote that? Negative x squared plus 1. There you go. So the vertex is up 1. It's this part of the graph. Because it's negative in front, it opens down. That's 1, and the graph is like that. What about that? X plus 1 all squared. If you get a question like this, look at the bracket. What makes the inside of the bracket 0? Negative 1. So it's moved the parabola to the left 1 unit. Does it open up or down? Up, because there's no negative in front. So it just looks like that. If it's bracketed with the square on the outside, you've moved the graph left or right. So it's tied up with the x. If the plus 1 or whatever is on the outside, not tied up with the x squared, then it moves it up or down. Okay, so if I wrote y is equal to negative x minus 1 all squared plus 2. Can you sketch that graph? Okay, what is the 1 on the inside with the x done? Which way did it go? Right or left? Went right, because 1 will make that whole thing 0. What does the 2 do here? And the negative makes it open. So basically, we went 1 this way, we went up 2, and we opened down. So if you wrote that, 1. Now, transformations is the next unit. This is just, I'm trying to get your brains going, because I know everybody's been on summer vacation. Basically, summer vacation, including for me, seems like it started in March of last year, all right? Because we haven't been here. I'm just trying to get your brains going in math. If this is a bit overwhelming, don't worry. It's just, this is the warm-up, right? We just got to get our brains going. I got to get used to teaching again. I would like you guys to do number 1, A, B, and C. I'll just give you like 5 minutes, and then we're gonna go move on. Okay, we left off here, moving parabolas around. We're gonna skip this bit. All right, we're gonna skip cubics because we basically do a whole unit on cubics. We're just gonna go right to the end here, page 4, functional notation. So hopefully this will be a review. For math, I think it's math 10, you first learn this, and then they use it again in math 12, or math 11. Above it? All right, so here's our function, x squared plus 4x plus 5. What type of function is that? Goes with a q. Quadratic. Forms a parabola. Okay. F of 2. The 2's in the brackets. Where does the 2 go in the function? It goes in for all the x's. So f of 2 just means 2 bracket squared plus 4 bracket 2 plus 5. Wherever there's an x, you put that in. And then you just solve it. What's 2 squared? 4. 4 times 2 is 8 and 5. 8 and 4 is 12 plus 5 is 17. All right. 2 times f of x. What's f of x? This whole thing. It just means 2 times all of this. And then what do you do with the 2? I like writing in red here. Just dump the 2 in. Remember, you can go old school and draw all the arrows if you really want to. You don't have to draw the arrows. So it's just 2x squared plus 8x plus 10. All right, next one, f of 2x. Whatever's in brackets goes where? In for x. So even though it's a 2x, that has to go in for all your x's. So this is 2x all squared plus 4 times 2x plus. What does 2x all squared mean or equal? What's 2 squared? 4. X squared is x squared. So that's 4x squared. 4 times 2x is 8x plus 5. Can't simplify any further than that. F of x minus 2. So if this is your function, why don't you, there we go. If this is your function, and it says that function minus 2, just go x squared plus 4x plus 5, back on a minus 2. What are the only like terms? The 5 and the 2, right? 5 minus 2 is 3. That's why you guys are in math. Squared plus 4x plus 3. All right, next one. F of x minus 2. Whatever's in brackets goes where? In for x. Why does this one suck? Because it's squared. So what it means is x minus 2 all squared plus 4 x minus 2 is 5. Now, why did I say it's going to be bad? What's x minus 2 all squared? Yeah, it's x minus 2 times x minus 2. So you have to FOIL it out, right? It's not x squared minus 4 or x squared plus 4. So I'm going to write it out the long way. You don't have to. If you can do it in your head, that's fine. The 4 gets dumped in here. 5 is just hanging out by himself. X minus 2 times x minus 2. FOIL it all. So x times x squared. X times negative 2 is negative 2x. And that and that. So it gets really big. but then we combine our terms. Is there any other x squareds there? No. That just stays by itself. Negative 2x and negative 2x is negative 4x. What's negative 4x plus 4x? 0x. So those are all gone. 4 minus 8 plus 5. All right. F of negative x. Whatever's in brackets goes in for x. And bracket it when you put it in. So I get negative x. So I'm putting in there all squared plus 4 times negative x plus 5. What is negative x all squared? Positive x squared. 4 times negative x is negative 4x plus 5. So that's why you bracket it. Because if you're squaring a negative, it flips the sign, obviously. It becomes positive. Okay. Any questions about that? All right. Consider the function, match each of these. Okay, so we're going to match these. Here's our basic function. F of x is equal to x cubed. The match the expression on the top with the function on the bottom. So we're kind of playing around with it in our head. So if I say x cubed plus 5, which one of these would represent that of these guys here? Well, if I know that x cubed is f of x, that is the same as saying f of x plus 5. So which one does it match? 3. Adler?
Oh, wow, look how long your hair is. You look so different. I always think it's a man gun. Yeah. Sorry to interrupt.
That's okay. I'm recording this, so I'm just going to leave that all in the recording. It's the only smart thing I do. Okay, does that make sense? So if I said, start with this. Let's work backwards. Let's do these bottom ones. So if I gave you this, f of x plus 5, which one of these would it generate? Where does anything in the brackets go? Anything in the brackets goes in for x. So if I put x plus 5 into that x, which one of them do I get? A, B, C, or D? Let's do it. I'm going to go bracket x plus 5 cubed. Which one does that match? C. What about number 2? Which one will that match? D, because anything, in the brackets is in for x. So it's 5x cubed. I've already done 3. Number 4, it's the only one that's left. See, anything in the brackets goes in for x, gives you that. Okay? All right. Last one before the break and the end of this lesson. Okay. If f of x is equal to x to the 4, write the following in terms of the function f. Okay. This is our function, f of x. They want you to rewrite all of these with an f of x. What's up? So just replace, if you see an x to the 4, replace it with f of x. So this is the same as f of x minus 4. These are just kind of working backwards and forwards and getting you used to the functional notation again. We'll save B. C. 2 times x to the 4. As soon as you see an x to the 4, what do you replace it with? F of x. So this is actually 2 f of x. Then we'll do D, and then we'll go back to B. 2x all to the 4th power. What would I write? I have to write f of what? F of 2x. Because whatever's in brackets goes in for x, right? And that would give us 2x to the 4th power. All right, what about B? So what is in the brackets raised to the 4th power? X plus 3, yeah. That means I'm going to have f of x plus 3, right? If I didn't have that 2, if I cover it up, you can't see it. Making sense. If I didn't have that 2, that would match, right? But we do have the 2. So what do I have to do to this? What do I have to add on to it? Just put a minus. Done. This again, warm up, getting your brain thinking about math again, because it's been a while, including me. Numbers 5 to 7, please. That'll take us up to the break. And then I'm not sure what happens at break. Do we have to walk you in? That part will not be in the video. So start with the square root. What's the square root of 81? 9. So it's negative of negative 9. Absolute value of negative 9 is 9. And there's a negative in front, so the answer is negative 9. Is that okay? Numbers 1 and 2, please. Give you a couple minutes, and then we will. So this is a definition of the absolute value function. I'm not going to ask you to memorize this or to know it, or we're not going to use it at all, but this is just what it is, okay? Absolute value is equal to the root of x squared, okay? The reason it's the root of x squared is because when you square something, it'll always be positive, okay? And then you get the square root of it. So essentially it's going back and forth. We use this in calculus to do some proofs and stuff. We're not going to use it in this class. This is another definition. It's equal to the value of x if x is greater than 0 and negative x if x is less than 0. So we're going to use this to kind of generate the graph. Has anybody ever seen an absolute value function graph before? I think you might have in grade 11, or it used to be in the curriculum. If I ask you to sketch that line, linear, curved, what? Linear, right? Because the exponent is 1. What is the slope of that line? 1. Does it have a y-intercept? If there's no value, what value is it? 0. So if you were sketching it, and remember it's only x value is greater than 0, so 1's on this side over here. So it's just a linear line that looks like that. What is the slope of this line? Negative x. What number's in front of the x? Negative 1. A negative slope, the slope's the other way, and has a y-intercept of 0. That is the absolute value graph. Looks like a V, but with a point. It's not curved like a parabola. They're two straight lines, but it is a V. Okay. Now, just to get you thinking and tie it into what we already know. So there's our y is equal to the absolute value of x. If I said y is equal to the absolute value of x plus 1, can you sketch that graph? What does the plus 1 do? Moves it up 1, right? Just like the parabola, x squared plus 1 moved it up 1, same thing. Now it looks like that. If I say absolute value of x, I'll put a negative. That's a negative. That's really not a good negative. Let me just erase all this. Negative absolute value of x. What does that graph look like? What does the negative do for a parabola? Flips it upside down. What does it do for this? Flips it upside down. It's the exact same thing. So it just looks like that. What if the 1 is inside the absolute value? What did the 1 do when it was inside the brackets of a parabola? So it was like x minus 1 all squared. It moved it left and right, right? Correct, I should say. So what does this do? Moves it left and right. What makes the inside of that 0? So that's your starting point. So it just moves it over 1, and it's still a v. It's the exact same as parabolas. Okay, and you're going to see in the next thing, the radicals are the exact same. Okay. Square root graphs. Okay, we'll just fill in this table. If I put -4 into there, can you square root a negative number? Not yet. Go to university, you'll learn how to do it. Can you square root negative? So -1 is out as well. Can you square root 0? What's the square root of 0? 0. What's the square root of 1? What's the square root of 4? Square root of 9. And 4. So if we plot this, 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. There's our graph. So you can see how it's sort of leveling off. Okay. That's what a radical graph, square root graph looks like. Okay. Explain why the domain of the function y is equal to root x is not the set of real numbers. Why isn't it all numbers? What numbers can you not square root? Negatives, because you can't square root negatives, right? So that's why. That's a dumb question. So I'm not even going to answer it here. All right. What is the domain of the function y is equal to root x? In other words, what numbers can you square root? Positive numbers, right? So the domain of it would be x. Can you square root 0? Not a shoulder shrug. Can you square root 0? Yes, you can, right? So we have to say greater than or equal to 0. Bad 0. So there's our domain. If we're going to do it in set notation, the brackets where we did negative infinity to positive infinity, what you would write is we start at 0 and we go, you can go to any number that's positive. So then we write infinity. Now, here's where a slight trick is. It's not a trick, it's just some notation. If you include the number, it has to be a square bracket. Okay, so that means it includes the number. And a round bracket means it's not included. So when I say includes a number, that's like greater than or equal to, or less than or equal to. All right? Is infinity a number? All right, it's not like one number. So it just basically means you go on forever and ever. So you can never really get there. So that is always going to be a rounded bracket. Okay, if there's an infinity, it'll always be a rounded bracket because that means number not included. Number not included. Remember, If you just write that, I'm happy with that. X is greater than or equal to 0. If you go on to calculus, this is the kind of notation you'll use. Okay. So there's the domain. We start at 0 and we go to bigger and bigger numbers, and you can see that on the graph because arrow here. What is the range of this function? In other words, what are the possible y values? What's the lowest y value? Where does it start? 0. And it goes up, right? Now it goes up gradually because this will flatten out, but it goes on forever. So we just say y is greater than or equal to 0. There's our range. If you wanted to do set notation, what would you write? The bracket notation, what would you write? Start with 0 and go to infinity. It's going to be the exact same thing. 0 to infinity, like that. Okay. Well, I want to sketch a few of these. We'll do them right here at the bottom. You'll note when I do these lessons, I tend to just kind of do little side mini lessons all over the place. So I apologize a bit for that. When we get into the guts of this course, I'll do less of that. It's just we're in review right now. So if I asked you to sketch this, root x plus 1. So remember, this is the basic graph of root x. Looks like this. Looks like that. So if I say root x plus 1, what does the plus 1 do? Moves it up 1. Just like parabolas, just like absolute value. All right? These are all the same. So this graph just looks like starts at 1 and then curves like that. If I say negative root x, what did the negative do for the absolute value? Flipped it, just like parabolas, right? So if this is our basic graph here, and I put a negative in front, flip that upside down. Again, this is in transformations. We'll study this in more detail. But it opens like that. Root x plus 2. So are we moving it up and down or left and right? Back up here. When the number was inside either the absolute value or if we did it with quadratics, what does it do? Doesn't move it up and down, right? It moves it left and right. To find out where it moves it left and right, just say, what makes the inside 0? So what makes the inside of this 0? Negative 2. So that's your starting point. So on your graph, go, okay, negative 2. Now you have to figure out which way it goes. This way, or that way. Test the number. What is the easiest number in the world to test? 0. So if I put 0 in here, I get 0 plus 2. Can you square root 2? Yes, you can. So that means that works. So it goes that direction. So we start here and we just draw that. That's all I have to do. If I did this, that 2 minus x. So you know it's moved it left and right because it's inside with the radical sign. What makes the inside of that 0? 2. So you mark your point. Now, test to see which way it goes. What's the easiest number to test? 0. So if I put 0 in here, what's 2 minus 0? 2. Can you square root 2? Yes. So that means the graph goes this way. If you put a 3 in, which is over here, what's 2 minus 3? -1. Can you square root -1? So it can't go that way. It goes that way. So it looks like this. Right? The trick is, if it's a number minus x, it opens the other way. Okay? We'll study this in more detail when we get into transformations. All right, last question for this lesson. Look at that, we're just burning through lessons. So we're going to sketch this, 2x minus 1. So we've moved it, what? Up, down, left, or right? If we're inside, we move it left or right. Okay. What makes the inside of that 0? If you don't see it right away, all you have to do, take the inside of it and just go, okay, what makes it equal to 0? And you can just solve the algebra. So you move the 1 over by 2. X equals a half. Okay, that is your starting point. So 1/2. Now you have to figure out which way it opens, left or right. So test a point. What's the easiest point to test? 0. If I put 0 into here, what's 2 times 0? -1. -1. Can you square root -1? Can it go towards 0? It has to go the other way. All right, I'm just going to do domain and range, and then you have a couple practice questions. Domain. All right, what's the domain of this? Just looking at the graph. Where do we start? Or can it be 1/2? So you have to say greater than or equal to 1/2. If you wanted to do the interval notation, it would be square bracket a half to infinity rounded bracket. What's the range? Yes. Starts at 0 and it goes up. So you could do 0 to infinity round bracket. There you go. All I want you to do is question number 7, please. At the top, the only thing we need to know from this page is what this stuff means. Okay, so basically this is composition of functions, which means you're putting one function into another function. Okay, you're combining the functions. So the notation, whoops, g bracket f of x, right? Which means f of x is going into g. So you read g of f of x. The other way you'll see it is it's written like this. A lot of people say goth. All right, because it's not an O, but sort of circle, open circle, so it looks like an O. It's g of f of x. You read it essentially right to left. This function on the right goes into that function. Okay, so if I wrote log this, f of g of x, what that means is the g is going into f, so it means f of g of x. So whatever g of x is gets put into f. Okay. We're going to practice this. Once you start practicing it, it makes it comes pretty quick. Although the book does it in an absolute weird way. So we're not doing the way the book does it with all these arrows, all this stuff. Ugh. We're just going to go right to the bottom of page 19. And here we go. So, g of f of x. So which function's going into which for this one? Let's go off right here. F is going to g, so that means this. G f of x. All right. So basically, what you should do is once you have it written this way, what is f of x? Here's our two functions. F of x is 2x squared minus 1, g of x is 3x minus 4. So instead of writing f of x in those brackets, just write what it is. It's 2x squared minus 1. Whatever's in brackets goes where? Goes in for x. In this case, it's going in for x of the g function, right? So it's going into that x right there. So it's 3 bracket, this whole thing, 2x squared minus 1, and then the minus 4 is on the outside. All right, now we got to simplify it. So dump the 3 in. Hello. You can. Okay. So what do I do with that 3? Yeah, just dump it in. So I get 6x squared minus 3, back on a minus 4. Combine your like terms, and you get, there you go, 6x squared minus 7. That is g of f of x. Simplifies to that. What about this one? G of x. GOG. What's going into what? G is going into g. So it means that. What's g of x? This function here. So I'm going to write g of 3x minus 4. And then where does the 3x minus 4 go? In for x. Anything in brackets goes in for x. So it's this 3. Instead of writing that x there, I write this stuff. 3x minus 4. Tack on the 4 at the end. And then dump the 3 in. 9x minus 12 minus 4. 9x minus 16. All right, I'm going to do one extra one here. So we're going to do fog of 2. So we don't have an x there, we actually have a number. All right, so here, the x, it kind of went like that, right? The f of x went into g. Well, this is really just saying that whatever g of 2 is going into F. So ignoring the F right now, let's just figure out what g of 2 is. So if I said, okay, tell me what g of 2 is. Where does that 2 go? It goes into g, right? It goes into the x in g right there. So you get 3 bracket 2 minus 4. 3 times 2 is 6. 6 minus 4 is 2. So that means g of 2 is equal to 2. Way too many 2's in this. So now I can write, instead of writing, do it in green, instead of writing this, I can just write here f of 2. Can you see that green? So then where does this 2 go? Goes into the x or the f function right here. So then it's just 2 bracket, should use a different number than 2, squared minus 1. Which is 2. 2 squared is 4. 2 times 4 is 8. 8 minus 1 is 7. If there is a number, rewrite it like this. 2 into g. Figure out what that is, and then just plug that into the other function. Any questions? All right, 6 and 8, please. And that is all we're doing for today. We can do more if you want, but you probably won't need to stop right now. 6 and 8, I will, and you can work on the other